You know that feeling when you're on a website and it just feels alive? When things update without a full page reload or an animation responds perfectly to your mouse? Yeah, that's JavaScript. It is literally the language that brings the web to life, the brain behind all the logic and interactivity we take for granted. When Jeff Atwood, the co-founder of Stack Overflow, first said this, it probably sounded pretty out there. A bold prediction for sure. But now, it's not a prediction anymore. It's just a description of reality. JavaScript is everywhere, and it's one of the most versatile languages on the entire planet. So here's a great way to think about it, a classic analogy that just works. If HTML is the skeleton of a building, giving it structure, and CSS is the paint, the windows, the style, the skin, then JavaScript, it's the brain, it's the nervous system, the elevators, the electricity. It's everything that makes the building actually do something.
Okay, so if we're going to build this skyscraper, the first thing we need is a blueprint, right? So let's start there. Let's take a look at what JavaScript actually is, where it came from, and why it was even created in the first place.
The creation story for JavaScript is just wild. Seriously, you have to picture the mid-90s. The browser wars are raging. Netscape desperately needs a simple scripting language, so they hire Brendan Eich and tell him to build a prototype. The catch? He has 10 days. And he actually did it. After that, it got standardized, but then it hit this lost decade with almost zero updates. And then, bam, 2015. ES6 is released, and it completely revolutionizes the language into the modern JavaScript we all use today.
So with our blueprint in hand, it is time to pour the foundation. Let's get into the absolute core building blocks of the language. These are the fundamentals that literally everything else is built on top of.
Okay, so think of variables as the actual bricks we're using to build. The original keyword var, well, it has some pretty quirky behaviors that could lead to bugs, but the modern standards let and const are so much safer. They introduced something called the temporal dead zone, which sounds complicated, but it's just a fancy way of saying you can't use a variable before you've declared it. That one simple rule just wipes out a whole category of common bugs. Here's a really simple rule to remember. In JavaScript, if a piece of data isn't one of these 7 things you see here, it's an object. That's it. These are the fundamental, unchangeable atoms of the language, the most basic pieces of data that everything else gets built from. All right, this one trips up pretty much everyone at some point, the difference between null and undefined. The best way to think about it is right here. Undefined is the system's default. It's JavaScript saying, I don't know what this is yet. But null, that's your choice as a developer. You are explicitly saying, I know what this is, and the answer is nothing. It's an intentional absence of a value. And now for JavaScript's secret superpower, prototypal inheritance. This is how objects can share and borrow properties from other objects. When you try to access something on an object, JavaScript checks if it's there. If not, it follows this hidden link, this prototype chain, up to its parent object to see if it has it. It's just like asking your parents for something if you don't have it yourself. This is the absolute heart of how code is shared and reused in JavaScript. Okay, our foundation is set. It's solid. Now it's time to put up the steel framework. This section is all about building the logic that gives our code structure and allows it to actually make decisions and do things.
All right, let's kick things off with a classic JavaScript puzzle, a real wait what moment. How on earth can an empty array be equal to false? This looks like a bug, right? But it's not. It's actually the result of some very specific and kind of weird rules around something called type coercion. And it's the perfect way to introduce how JavaScript thinks about equality.
And here's the solution to that puzzle. The double equals, or loose equality, tries to be helpful by automatically converting types before it compares them. But that help often leads to really unpredictable, chaotic results. The triple equals, or strict equality, is way safer. It checks the value and the type. So is the string 5 the same as the number 5? Nope. Case closed. The takeaway is simple. Just always prefer strict equality. So functions are like the cranes and heavy machinery on our construction site. They're what actually does the work. A declaration gets hoisted, meaning you can call it before you've defined it. An expression doesn't, which gives you a bit more predictable control. But the real game changer here is the modern arrow function. Its superpower is how it handles the this keyword. It doesn't get its own, it just inherits it from its surroundings. This one change solved an entire category of incredibly common bugs. With that steel framework in place, it's time to install the building's internal systems. We're talking about the plumbing, the wiring, the elevators, all the parts that let our application interact with the world and handle things that take time without grinding to a halt. So we've written all this JavaScript code, but how does it actually connect to the web page itself? The answer is the Document Object Model, or DOM. You should think of the DOM as a live, interactive blueprint of the web page that our code can read from and write to. And JavaScript uses things called DOM APIs as its tools to edit that blueprint. So right here, we're using a specific tool to find our button by its ID, and then we just reach in and change its text, just like that. This is the fundamental bridge connecting your script to what the user actually sees. Okay, but what if a task is going to take a long time, like fetching data from a server halfway across the world? That's where asynchronous programming saves the day. It's like our building's elevator system. It can go off and handle a long-running request without stopping all the work on every other floor. And the best part is, the modern async await syntax makes this really complex process look incredibly clean and simple. All right, our building is up and running, but we're not just building a small house here. We're building a massive skyscraper. And for that, you need more than just systems. You need floor plans. You need advanced architecture to manage all that complexity at scale. Just look at this to see how much things have evolved. The old way of getting data from a server was this tangled, complicated mess called XHR. It was not fun. Now we have the modern Fetch API, which is built on something called promises. And when you combine it with async await, you get a super clean, intuitive, and readable way to handle network requests. It's a world of difference. So as your application gets bigger and bigger, how do you stop it from becoming one giant, chaotic mess? Well, you use architecture. Classes are like blueprints that let you create lots of consistent objects. And modules are really the foundation of modern JavaScript projects. They let us split our code into separate reusable files with import and export. It's how we keep things sane. Our skyscraper is built, it looks amazing. But before we can open the doors to the public, we have to do one last thing. The final inspection. We need to make sure everything is running efficiently and there aren't any hidden problems that could slow things down. One of the coolest features of JavaScript is that it automatically cleans up memory for you. It's like having a built-in cleaning crew. It uses this clever algorithm called mark and sweep. Basically, the engine starts at the roots, like your global variables, and follows every connection, marking everything it can reach as in use. Then it does a second pass and sweeps away anything that wasn't marked. This is absolutely crucial for preventing memory leaks that can kill performance. So there you have it. We've walked through the entire blueprint. We started with a foundation of variables and data types, we erected a framework of logic and functions, and we installed the advanced architecture of modern applications. You have the full roadmap. The only question left is, what are you going to build with it? The JavaScript Roadmap is a journey in itself, but it also connects to everything else, front-end, full-stack, and even back-end development. No matter which path you're on, this is the language you're always going to come back to. This is Developer Roadmaps. Map your path. Build your career.